Hello everyone, welcome to the solution of LeetCode problem 979 named Distribute Coins in Binary Tree. In this problem, we are given the root of a binary tree with AND nodes where each node of the tree has sum of the value which is represented by the coin. Now there are AND coins in total throughout the whole tree. In one move, we can choose two adjacent nodes and move one coin from one node to another. The move may be from parent to child or child to parent. And we have to return the minimum number of moves required to make every node have exactly one coin. Suppose in the first example, the root 3 has two children, 0 and 0. So root 3 has 3 coin. So in one move, we can move one of the coin to its left children, and in one move, we can move another coin into its right children. So by the two move, all of its left, right, and root will contain one coin. So we have to return 2. Now, in the second example, the root is 0, which has two children, 3 and 0. Now here this left children 3 has 3 coins. So in one move, we can shift one coin to the root, and by using the two moves, we can shift another coin to this 0. So in total, there are 3 moves needed. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the first example. Now we will solve this problem by using the DFS. And initially, the DFS call will start from the root. From the root 3, we will go its left children, which is 0. And from 0, it has two children, both of them are null. So we will go its left children. So as this is null, it will return the 0. Now from 0, we will go its right children, and it will also return the value 0. Now, the left children and right children of the node 0 is returning the value 0. So 0 will return the root's coin, which is 0, plus left surplus or deficit, which is the return value of the left subtree, plus the right surplus or deficit, which is the return of value of this right subtree, minus 1. So it will be minus 1. Now, what basically this minus 1 means? This minus 1 basically indicates that it has the deficit of coin 1. That means it have to borrow one coin from any of its children or parent. So here, for this, let's take an answer vector or answer variable and initialize it with 0. Now the answer will be 0 plus absolute of its left value, which is 0, plus absolute of its right value, which is 0. So till now, for this node 0, the answer will be 0, and its return value will be minus 1. That means it has 1 coin deficit, which it have to borrow. Now we are at the node 3, and we will go its right children 0. Similarly, for the right children, its both left and right child is returning the value 0, and the right children also will return the value minus 1 because it has 1 coin surplus. Now the answer will be again 0 plus 0 plus 0. So till now the answer will be 0. Now root 3 is receiving minus 1 from the left subtree and minus 1 from the right subtree. So here the answer will be current answer 0 plus absolute value of minus 1 plus absolute value of minus 1, which will be 2. And 3 will return the value root's coin, which is 3, plus its left surplus, that means minus 1, plus its right surplus, which is -1, then -1. So why we are expecting -1? Because each node must have one coin in it. So it will be 0. That means 3 minus 3. Now the root 3 will return the value 0. So here, so far, we have completed the iteration and our root node is returning the value 0 and our current answer is 2. So by taking the decision for each of the node, the current surplus or deficit for each of the node will be root's coin plus its left surplus or deficit plus its right surplus or deficit -1. And by using this equation, we can get the minimum time it needed to distribute the coin throughout the whole tree. The overall time complexity of this algorithm is big O of n. I hope you understood the algorithm. Now let's move on to the code. Now here, the code is pretty simple. At first, we are given a function named distribute coins, which has a root as a parameter. Now, we are calling a DFS function in the root, and inside the DFS function, if the root is null, we have to return 0. Otherwise, we have to recursively call the DFS function into the left and right subtree and store the return value into a variable and calculate the answer, which will be answer plus equal to absolute of left subtree plus absolute of right subtree. And we have to return the value, which is the root value plus left plus right -1. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.